Talking now about some respiratory or pulmonary volumes. And this is a graph showing you some of these volumes we're going to talk about here in just a second. We've got tidal volume, or V sub T. This is just resting tidal volume. You breathe in, you breathe out, you breathe in, you breathe out. Then when you breathe out at the very bottom of your respiration, your normal breath, and then you breathe out forcefully and you get rid of all the rest of the air that you can, that this volume here is called the expiratory reserve volume. That's all the air you can possibly force out of your lungs. So you're at this lowest volume that you can forcefully do physically yourself, that you're able to eliminate. And then you breathe back up, and you do another normal breath in and then out, and then in. And then if you were to take a deep breath at the top of your tidal volume and breathe in all the air you possibly can hold, this volume here, from your maximum of your tidal volume to the very maximum that you can possibly hold, that's called your inspiratory reserve volume. And then so these are different volumes that you can actually measure. Then we'll be talking about some capacities that are things that we calculate. And so if we add together the inspiratory reserve volume and the tidal volume, then this is called the inspiratory capacity. And then if we add together your inspiratory capacity and your expiratory reserve volume, then we get this big volume here called your vital capacity. That is the capacity, your maximum capacity to breathe while you're living, while you're able to move breath. Now, this volume down here we didn't talk about is called the residual volume. This volume here is the volume of air that's left in your lungs that cannot be forced out by you, but it simply remains in your lungs in your air passages. And so if you add that residual volume to your vital capacity, then you get the total lung capacity, which means every little bit of air that can possibly be held by your lungs. So those are some of your respiratory or pulmonary volumes. So these are the measured pulmonary volumes I mentioned: the resting tidal volume, the amount of air that you breathe in or out during a single respiratory cycle at rest. And it is good to look at the graph, and see approximately how many mLs it is. About half a liter is the volume of a normal tidal volume, and that varies between men and women a little bit. The expiratory reserve volume is the amount of air that you can voluntarily expel after you have completed a normal quiet respiratory cycle. Your residual volume is the amount of air remaining in your lungs even after a maximal exhalation. And then your inspiratory reserve volume, or IRV, is the amount of air you can take in over and above the tidal volume. Now, these are the respiratory capacities that are calculated. These are done by adding some of the volumes together. Your inspiratory capacity is the amount of air you can draw into your lungs after you've completed a quiet respiratory cycle. So it's the sum of the tidal volume and the IRV. Your functional residual capacity is the amount of air in your lungs after you've completed a quiet respiratory cycle. It's the sum of your ERV and your RV, meaning your expiratory reserve volume and your reserve volume. The ERV is the expiratory reserve volume, and then the RV is the residual volume. Sorry about that. Okay, and then your vital capacity is the maximum amount of air you can move in or out of your lungs in a single respiratory cycle. So it's the sum of your ERV, your V sub T, or your tidal volume, and your IRV. So you'll want to look at these volumes back on the graph. If again we look at the vital capacity is your IRV, which is the purple range, your total lung capacity, and your expiratory reserve volume. So that's your vital capacity. And then your total lung capacity is your vital capacity plus your residual volume. Again, looking back at your picture, you can see your vital capacity plus your residual volume gives you your total lung capacity. Okay, so we're getting ready to now talk about external respiration, the gas exchange between the lungs and the blood, between your alveoli and your plasma. So let's talk about that part. Before we do so, we need to talk a little bit about some of these gas laws and the fact that when you have a gas, it will there will be and you have a liquid and you've got gas. You've got this initial equilibrium state where the gas that's dissolved in the liquid will go up into the atmosphere around it, and it will go back and forth in kind of an equilibrium state. Now, if you put pressure on this and you push down on this little lid and put pressure on it, you're going to force more of that gas into the liquid. And let's pretend this is blood. So at greater pressure, you're going to force more gas into the liquid. And if you raised the lid to decrease the pressure, then you would allow more of the gas to come up out of the liquid and get into the air space. So the similarities would be if you have an unopened soda can, the gas is dissolved in the liquid, the gas bubbles of carbon dioxide, and then there's a little bit of airspace, but your volume is closed. If you open the can, then you allow this gas, then the gas will reach equilibrium and it will come out of the can, and then it will, there will be more gas out here and less dissolved. So the amount dissolved in your blood depends upon the pressure, the partial pressure of the gas. So diffusion depends upon the partial pressure of gases, the delivery of air to the lungs, the pulmonary blood flow, the surface area for exchange, and the diffusion distance. So we will we'll start talking about the partial pressure of various gases in the air, the alveolus, in oxygenated and deoxygenated blood, and your tissues. Now this picture, I know, is really this little table is a little bit confusing. All it is showing you that just the different partial pressure, or PO2 means the partial pressure of oxygen, and PCO2 means the partial pressure of CO2. PN2 means the partial pressure of nitrogen gas, and then water is just water vapor. And these are the gases that are in the atmosphere, the air. Okay, so just look at these. You do not have to memorize these. Do not get scared of this picture, of this little table. This is just for informational reasons, or just to look at. So you've got partial pressure of oxygen in your atmosphere, and then the oxygen will then get into your alveolar air in the alveolus. It would be right in here, and it's the partial pressure is about 100 at this point. It starts out at 160 in the atmosphere. In your alveoli, it's about 100. It gets into your oxygenated blood, it's about 100. And then by the time it gets to your tissues, there's only about 40 partial pressure. And then in your deoxygenated blood, there's only about a 40 PO2. Whereas for your PCO2, again, it is going to be a certain amount in the atmosphere, in your alveoli. It'll be a certain amount in your oxygenated blood, and in your tissues, and in your deoxygenated blood. And we're going to look at these in a picture that will make a little bit more sense as we go along. So again, do not memorize this. Some of you might be interested in these values just to kind of get a sense of what's happening, but don't get scared by it. Now this is the picture that makes the most sense, and this is the most helpful. This picture up here is a picture of what's happening in external respiration, where you're breathing air in. This is showing you the pulmonary circulation here, where, remember, the blood is going from your right ventricle, it's going to your lung. Here now we've taken a little chunk out of the lung here, capillaries in the lung, and there's your alveolus, and your PO2, your partial pressure of oxygen, is 100 in the alveolus, and the blood that's coming in through your little pulmonary artery, and then the arterial end of the capillary, the PO2 is only 40 because it's coming back from your tissues. So the oxygen's very low here. So notice the big difference between 100 and 40, PO2 of 100 and a PO2 of 40. Obviously the oxygen is going to go from the area of greater to lesser. It's going to move into the capillary. And at the same time, we see what the PCO2 is of this blood that's coming from the tissues. It's come and been sent to the lungs to pick up oxygen, get rid of CO2. PCO2 is 45 here, but the PCO2 in the alveolus is 40. So which way is CO2 going to go? Well, of course, it's going to go from the greater to the lesser, from 45 to 40. So CO2 is going to move out of the capillary, pulmonary capillary, into the alveolus, and you'll breathe out the CO2. So gases are always going to diffuse in the direction down their concentration gradient. They're going to go from area of greater to an area of lesser pressure. So let's say now that now the blood is going to then return to your heart, the left atrium. It's going to come back then down to the left ventricle, then it's going to go out all to your body tissues. And let's say now we're going to take a little snapshot of what's happening at a systemic capillary. So now here comes the blood. At this point, the PO2 has gone from about 100 to about 95, it's still pretty high. So there it is. This is just showing you a little picture of various tissue cells. And here in the tissues, the PO2 is about 40. It's low because the cells have used up oxygen in cellular respiration. So the PO2 is then is greater in the capillary, in the systemic capillary. So O2 is going to move into the tissues from greater to lesser. At the same time, these cells have been producing CO2 in cellular respiration. And now the PCO2 is 45 in the tissues, and the PCO2 in the blood in this area is 40. So the CO2 is going to go from an area of greater to lesser concentration, 40 or greater pressure. It's going to go from greater to lesser pressure, 45 to 40. So now the CO2 will then enter the systemic capillary, and the PCO2 is then going to come up to 45. The PO2 is going to be dropping down to about 40 because it's being used up, and this blood then is now going to then return back to the heart, right? It's going to come back to the right atrium, go to the right ventricle, and then get sent back to the lungs, where then it's going to go back. Now this part here where the gas is exchanging between the alveolus and the pulmonary capillary, this is called external respiration. And then here in the tissues, the gas exchange between the systemic capillary and your body tissues is called internal respiration. So please refer back to your notes about internal versus external respiration. But this picture is really a to-know picture. You really, really need to understand this one. Okay, this is a good place to stop. We'll take up with minute volume next time. Thanks.